Yes. Hello everyone, this is D. Chinnagokari. So welcome to our chemistry channel, that is Chemistry Masters Academy. So in this video lecture, I am going to explain about the chemical kinetics, one of the most important concept in physical chemistry. So and it is also very important concept for the IIT JEE mains. In IIT JEE means at least two questions they will ask in the mains level, even in advanced level also they will ask questions. In NEET level also it is one of the important concepts. So now let us start our chemical kinetics chapter. Okay. So here what is chemical kinetics? Chemical kinetics it is a branch of physical chemistry. So it is a branch of physical chemistry which deals with the which deals with the first one rate of reaction. Second one factors affect the rate of reaction. Next, third one, mechanism of the reaction. Mechanism of the reaction. First of all, rate of reaction. What is a rate of reaction? So here, rate it is nothing but speed of reaction. It gives information about the speed of reaction. So in the case of automobiles like bus, car, scooter, like that, the speed of the automobile or the vehicle we can express displacement by time or distance traveled by time. That is nothing but speed of an automobile. But in the case of a chemical reaction, so what is the speed of a chemical reaction or what is the rate of a chemical reaction? So here chemical reaction is nothing but conversion of a reactant into product. Conversion of reactant into product. So here simply we can give the rate of reaction or speed of reaction is nothing but time required. Time required to complete time required to complete a chemical reaction. Chemical reaction. Which means it gives information how much time it is required to convert a reactant into product. So based on this time required, so there are three type of reactions are there. So based on the time required, there are three type of reactions. So that is, the first one is very fast reactions. Very fast reactions. So what is a very fast reaction? The reaction which can occur within fraction of seconds. The reaction which completes within fraction of seconds. Within fraction of seconds. Within fraction of seconds. Such type of reactions are called very fast reaction. So here, how much time is required to complete a chemical reaction? That is 10 to the power of minus 12 to 10 to the power of minus 16 second inverse. So within this time only they are going to be completed. So such type of reactions are called very fast reactions. So here we can take the examples of very fast reactions, that is ionic reactions. Ionic reactions are very fast reactions. For example, AgNO3 silver nitrate in the aqueous medium plus NaCl in the aqueous medium, they are going to react together. They produce AgCl, a white precipitate, PPT. PPT means precipitate, and NaNO3. So this reaction takes place within fraction of seconds. So here we cannot measure the time also. So such type of reactions are called very fast reaction within fraction of seconds, which means in this time only they are going to be complete. That's why they are called very fast reactions. So here when you mix the sodium chloride and silver nitrate, immediately we can observe the formation of silver chloride white precipitate and sodium nitrate. We can observe this is also called silver mirror. Silver mirror. Next, one more example we can take BaCl2, barium chloride plus sodium sulfate, Na2SO4, aqueous medium. It is also in the aqueous medium. So they are going to react together to produce barium sulfate. Barium sulfate, a white precipitate again we will get here, plus 2NaCl. 2NaCl. So this is also very fast reactions. Here ionic reactions are very fast reactions. Why the ionic reactions are very fast reactions? So that reaction is not visible in here. Now I am writing the same reaction here. BaCl2. So here BaCl2 plus Na2SO4 is gives rise to BaSO4 white precipitate. We observe formation of white precipitate and 2NaCl. So this is very fast reaction. Next, coming to neutralization reactions. Neutralization reactions are also very fast reaction. Neutralization means acid indicates H plus, OH minus indicates base. They are going to give salt plus water. So such type of reactions are called neutralization reactions. Your neutralization reactions are also very fast reactions. For example, HCl plus NaOH is gives rise to H2O plus NaCl, salt plus water. So all these reactions are very fast reactions. And also explosion reactions. Explosion reactions. Explosion reactions are also very fast reaction. For example, explosion of TNT. Explosion of TNT, trinitrotoluene. Explosion of trinitrotoluene, TNT. NO3 or CH3 you keep here, NO3, NO3 and NO3. So this is the trinitrotoluene. Explosion of trinitrotoluene is one of the very fast reaction. Next, coming to very slow reactions. Very slow reactions. What are the very slow reactions? So the reactions occurs days, months, years together. Such type of reactions are called very slow reactions. So the reactions which occur, the reactions which occur in days, months, years together, years together are called very slow reactions. For example, formation of water. H2 plus half O2 is gives rise to H2O. H2 plus half O2 is gives rise to H2O. So according to thermodynamic data, it is a spontaneous reaction. According to thermodynamic data, it is a spontaneous reaction. Why? Because delta H is negative. It is a spontaneous reaction, but it takes much time to form water at 25 degree Celsius. And also rusting of iron. Rusting of iron. Rusting of iron also is very slow reaction. So we already know rusting of iron means a formation of brown color layer on the iron objects. That is called rusting of iron. So rusting of iron 4Fe plus 3O2 is gives rise to plus x moles of water is gives rise to 2Fe2O3 XH2O. So this is also very slow reactions. We already know rusting means the formation of brown color layer on the iron objects in the presence of oxygen and moisture, air and moisture. So this is the formula of rust. Okay, so these are the very slow reactions. So generally covalent reactions are very slow reactions. Why the covalent reactions are very slow reactions means, so in covalent molecules there is a necessity of breaking of bonds. Compulsory we should break the old bonds, then after we should form the new bonds. To break these old bonds it takes much time. So that's why the covalent reactions are slow reactions, whereas ionic reactions are very fast reactions. Next, another category, that is moderate reactions. So next category of type of reactions, that is moderate reactions. Moderate reactions. So here, what are the moderate reactions? So the reactions which completes the reactions which completes the reactions which completes within minutes or hours. Within minutes or hours are called moderate reactions. For example, we can take example, number of examples are there. Formation of ammonia. You can take formation of ammonia. N2 plus 3H2 is gives rise to 2NH3. N2 plus 3H2 is gives rise to 2NH3 in the presence of iron and molybdenum. Next, inversion of cane sugar. Inversion of cane sugar. Inversion of cane sugar. Cane sugar formula C6H12, sorry, C C12H22O11 in the presence of water So it becomes as C6H12O6 plus C6H12O6. This is called inversion of cane sugar. So here means sugar molecule is dividing into glucose and fructose. Glucose and fructose. This is called inversion of cane sugar. So this is one of the example of moderate reaction, and SO2 plus half O2 is gives rise to SO3. This is also example of moderate reaction, and decomposition of hydrogen peroxide H2O2 is gives rise to H2O plus half O2. This is also example of moderate reactions. So this is about different type of reactions based on the time required to complete the chemical reaction. Based on the time required to complete the chemical reaction, there are three type of reactions, that is very fast reactions, very slow reactions, and moderate reactions. So here, this laws of chemical kinetics, what we study in the laws of the or these concepts of chemical kinetics applicable for only moderate reaction. We can apply for only moderate reactions, but we cannot apply for the slow reactions as well as very fast reactions. Why we cannot apply this laws of chemical kinetics for very slow reactions and very fast reactions? First, let us come to very slow reactions. In very slow reactions, we cannot observe any measurable change in the concentration. For example, rusting of iron. So, in the case of rusting of iron, so the fresh iron is in the black in color. When you expose to the air and moisture, after 1 or 2 days, we observe some black spots or brown color spots, some brown color spots on the iron object, and then after for a week, we observe just like a powdery mass, and then after 1 or 2 months, we can observe some flakes of rust over the iron. Means likewise, it will take more time duration so that we cannot observe any measurable change. That's why we cannot apply laws of chemical kinetics for the this very slow type reactions. And when you come to the very fast reactions, so in very fast reactions, so within short time only they are going to be complete, so that we cannot measure any time there. That's why we cannot apply the laws of chemical kinetics for the very fast reactions and very slow reactions, but we can apply the laws of chemical kinetics for the only moderate reactions, such type of reactions. Next to we will study type of rates. First of all, rate. So let us give the proper definition of rate of reaction. Rate of reaction. Okay. So we already know the rate of reaction means the time required to complete the reaction. Means let us see for a hypothetical reaction, reactant converting into product. Okay. So here, as time proceeds, the concentration of reactant is decreases, the concentration of product is increases. The concentration of reactant decreases and the concentration of product is increases. So that what is the rate or rate of reaction? Rate is equal to decrease in the concentration, decrease decrease in the decrease in the concentration of reactant by time, or we can write rate is equal to increase in the concentration, increase in the concentration of product, increase in the concentration of product by time. Okay, so when you, so in the graphically means when you draw a graph between the concentration and rate, oh sorry, concentration and concentration versus time. When you draw a graph of concentration versus time, so now let us take it is the concentration, it is the time coordinate, so it is the initial time t t1 t2 t3 like and so on is there, and this is the concentration c1 c2 c3 likewise concentration is increasing. Okay, at initial time concentration of reactant is very high, at initial time concentration of reactant is very high. As time passes the concentration of reactant is decreases like this, and at initially the concentration of product is zero, so as time passes the concentration of product is increases. So this is this curve represents the increase in the concentration of product, this curve represents the decrease in the concentration of reactant. Okay, so that is about the rate of reaction, and how to write the mathematical expression for the rate of reaction. So here, what is the mathematical expression of the rate of reaction? That is, so mathematically how we can define the rate of reaction means the increase in molar concentration, or the change in molar concentration. That means the change means that maybe increases or decreases. The change in molar concentration of reactant, molar concentration of any any one of the reactant, any one of the reactant or so the change in molar concentration of any one of the reactant or any one of the product, that is called rate of reaction. So here, how to express the mathematically the rate of reaction. Now let us take one hypothetical example so that we can apply for each and every reaction. So now let us take the one of the hypothetical equation and let us try to understand the rate of expression, how to express the rate of reaction mathematical. Let us take the hypothetical equation. So here A moles of A is reacting with B moles of B to give C moles of C plus D moles of D. So for such type of reactions, how to express the rate? So now here rate is equal to, so we already know decrease in the concentration of reactant versus time or by time. So here more or the proper definition is the change in the molar concentration for 1 mole. So means 1 by A delta of A by delta T. So here we are keeping the minus value. So why we are keeping the minus signs here, I will explain you later. So first let us write it. Minus 1 by B, change in concentration of B by change in time, that is equal to 1 by C, change in concentration of C by change in time, that is equal to 1 by d change in concentration of d by change in time. So this type of expression, it is also called average rate. Average rate, it is also called average rate. So now let us come to here these mathematical terms. So rate is equal to 1 minus 1 by a change in concentration of by change in time. So that is equal to minus 1 by b change in concentration of b is equal by change in time, that is equal to 1 by c change in concentration of c by change in time, that is equal to 1 by d change in concentration of d by change in time. Which means how to express mathematically. First, let us observe with respect to a. So with respect to a, what is the rate here? Minus 1 by a delta a by delta t, delta of change in concentration of a by change in time. So here why we are writing 1 by a means here a moles of a is there, but we are taking for only 1 mole. That's why we are dividing with a with 1 is dividing with a, so that we will get for 1 mole. Okay, that is the reason. And why we are writing minus sign when you are writing the rate of the reaction with respect to reactant, but there is no minus sign when you are writing the rate of reaction with respect to the concentration of products. See here, what is the delta a means here? Delta a means change in concentration, change in concentration. Delta A means change in concentration. So change in concentration means final concentration, final concentration minus initial concentration. Change in concentration means final concentration minus initial concentration. So as it is a reactant, as reaction proceeds, concentration is decreases, concentration is decreases, so that final concentration is less, and whereas initial concentration is more. So less minus more will get minus value. To convert this minus value into positive value, we are going to multiply with the minus sign. So why we need to express in the positive way only means, because rate is always we should express in the positive manner only. We cannot express the rate in the negative value. See, for example, if an automobile is moving from one place to another place, how we express the rate? For so and so kilometers per hour, like that we will express, or 10 kilometers per hour, 30 kilometers per hour, like that we can express. But we cannot express minus 10 kilometers per hour like that. So it is not possible. Like that, here also rate value should express only in the positive values. But here change in concentration of A means final concentration minus initial concentration. Here final concentration is less, initial concentration is more, so that we are getting negative value. To convert the negative value to positive value, we are multiplying with the minus sign. That is the meaning here why we are multiplying with the minus sign. Okay, so this is called average rate. So now let us write the this average rate for a real equation, that is let us take H2 plus I2 is gives rise to 2HI. For this reaction, how to write the average rate? So here average rate is equal to how we can write? So here what is the coefficient? 1 is the coefficient, minus 1 by 1 dH2. dH2 means molar concentration of H2 by, or delta H2 by delta T, that is equal to minus 1 by 1 delta I2 by delta T, that is equal to 1 by 2 delta hi by delta t. So this is the average rate. So here this is about way of writing of average rate. Okay. So here when so we know that when you are writing a product reactant means we'll write with the negative sign. But when you are writing it in the case of products means there is no need of negative sign. Why? Because the concentration of product is increases as time proceeds, so that the final concentration is greater than the initial concentration. Automatically here you will get positive value only, so that no need to write again negative sign here. So that's why we are not writing any negative sign here. So 1 by 2 delta hi by delta t. So likewise, if you measure the change in concentration by change in time for a long duration of time, that is called what? Average rate. So what is the meaning of average rate? Means calculating the rate for a long time duration, that is called average rate. Calculating the rate for long time duration, that is called average rate. And one more rate of reaction is there, that is instantaneous rate. So what is instantaneous rate? So instantaneous rate means instantaneous 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 rate. So instantaneous rate equal to instantaneous rate means measuring the rate of reaction for a short time, for a particular time, at a particular time. Measuring the measuring measuring the rate of reaction, or calculating the rate of reaction at a particular time, at a particular time, particular at a particular at a particular time, that is called instantaneous rate. Measuring the rate of reaction at a particular time, that is called instantaneous rate. So instantaneous rate we can calculate calculate for a small change. Can calculate for a small change, not for a large change. This small change indicated with this small change indicated with small d. Okay. So for this reaction only, for this hypothetical reaction only, how we can write the instantaneous rate? A moles of A is reacting with B moles of B, which gives rise to C moles of C plus D moles of D. So for this reaction, how we can write the instantaneous rate? So here instantaneous rate, so rate, instantaneous rate, instantaneous rate is equal to minus 1 by A by dA by dt, that is equal to minus 1 by B dB by dt, that is equal to 1 by C dC by dt, that is equal to 1 by D d d by dt. So this is the instantaneous rate, and this is the average rate. So what is the difference here? In average rate means for a long time duration, that is indicated with the small capital delta. This is called capital delta, and this is small d. Small d indicates small change in the concentration and small change in the time. So here for example, here it is the reactant is converting into product. So so we are going to draw a graph here between the concentration versus time coordinate. So here we already know as the reaction proceeds, the concentration decreases gradually. As the reaction proceeds, the concentration decreases gradually. So if you want to calculate the rate of reaction at this particular instantaneous time, at this particular time, so that what we are doing here, we are drawing a tangent which touches to that point, and we are extrapolating equally at same distances. For example, so we want to calculate the rate at 600 seconds, so we extrapolate 400 seconds to and 800 seconds likewise, so that delta t 800 minus 400 will become 600. Okay, so at equal distance, and again here we are taking the concentration. So this is the small change in concentration of air. This is the small change in the time, and here we'll get the slope. Slope is equal to dA by dt. Slope is equal to here dA by dt. Change in concentration versus by change in time. So this is the average rate and instantaneous rate. Okay, and next let us discuss about the rate of formation and rate of decomposition. And before that, units of rate of reaction. So what are the units of rate of reaction? So here rate of reaction means we already know change in concentration by time. Concentration by time means concentration, here we are taking molar concentration, that is moles per liter time inverse. Moles per liter time inverse. If gaseous substances are involved means atmosphere time inverse. Atmosphere time inverse. If gaseous substances are involved, that is atmosphere time inverse. This is the units, the rate. Next, some small important concept is there, that is rate of formation and rate of decomposition. So, rate of decomposition and rate of formation, or simply it is known as rate of change in concentration. Rate of change in concentration. Okay. So, how to understand this rate of decomposition, rate of formation? So, before that, I will take a general reaction, that is 2 moles of A is converting into 3 moles of B. 2 moles of A is changing into 3 moles of B. So in that case, how we write the rate of reaction? First of all, rate of reaction. What is the rate of reaction here? Rate of reaction with respect to reactants, that is minus 1 by 2 change in concentration of A by change in time, that is equal to 1 by 3 change in concentration of B by change in time. This is the rate of reaction. We already know. Then what is the rate of change in concentration, or rate of decomposition, disappearance, or rate of formation? Means simply how much of the concentration of A is utilizing, and how much of the concentration of B is producing. How much of concentration of A is decreasing, how much of concentration of B is increasing. That is the rate change. So that is called first rate of disappearance. Disappearance. In rate of disappearance, just we are writing minus dA by dt. So here we are not using these coefficients, or it is also called rate of decomposition. Rate of decomposition. Okay. Next, rate of formation, rate of formation, rate of formation, it is of B, rate of formation of B, that is here also dB by dt, dB by dt. So here what is the relation between the rate change in concentration of A and the rate of reaction? So here we already know rate of reaction with respect to A, with respect to A, that is minus dA by dt, that is equal to minus, in this reaction, minus 1 by 2 dA by dt, that is the rate of reaction, rate of reaction, ROR. And if you send this to that side, minus 1 by dA by dt, that is equal to 2 into ROR. So this is rate of decomposition, rate of decomposition of A. So the rate of decomposition of A is equal to 2 into ROR. In the same manner, rate of formation of B will be rate of formation of B will be 3 into ROR. So this is about the rate of reaction and rate of decomposition and rate of formation or rate change in a concentration. Okay. Now let us take one example illustration to understand clearly what is the rate of reaction and rate of decomposition, rate of formation. So now let us come here. For a reaction, 3A plus 2B is gives rise to the rate of decomposition of A is they given 1.0 into 10 to the power of minus 1 moles per second, means molar per second or mole liter inverse per second, and they ask us to calculate rate of reaction, rate of formation of B. Okay, so first rate of decomposition of A minus dA by dt, they given how much, 1.0 into 10 to the power of minus 1 mole liter inverse second inverse, and we need to find out the rate of reaction, ROR. ROR with respect to A, that is minus 1 by 3 dA by dt. Therefore dA by dt minus dA by dt value, that is 1 by 3 minus dA by dt value 1.0 into 10 power minus 1 mole liter inverse second inverse. So that is 0.34 into 1.0 into 10 power minus 1, or simply 3.4 into 10 power minus 2 mole liter inverse second inverse. That is the rate of reaction and rate of formation of B. So as we know, the rate of formation of B is 2 times of the rate of reaction. Therefore rate of formation of B, rate of formation of B is equal to 2 into ROR, rate of reaction, that is B is equal to 2 into rate of reaction, that is 3.4 into 10 power minus 2. Therefore 6.8 into 10 power minus 2. This is the solution for that rate of formation, rate of reaction relations from this relation. Okay, thank you for watching.